This is podcast group 27, and today we'll be discussing the application of the mathematical concepts that we have been taught during MATH123 at Macquarie University.
Students often wonder why they are actually studying math. They think they will not need it in real life, but math can easily be used and is often used to make our everyday dreams come true. Our dream is to start up a business, and the main focus of a business is to maximize our profit. In this podcast, we of Group 27 will show you that even simple math concepts and very little data can be used to increase the profit in even simple business models.
Let's say we have a business which sells only one product, apples. To predict our profits, we decided to experiment with the prices. The original price was $5 for a kilo, and we sold approximately 10 kilos a day. So we changed our price to $4 a kilo, and we sold approximately 15 kilos a day. With this information, we have 2 points in a graph. From here, we can use the 2-point formula for a straight line. In this example, we have change in quantity over the change in price multiplied by P minus P1. This will equal Q minus Q1. With Q and P being the variables, we can work this out to be Q equals 35 minus 5P. This is now our function for the quantity sold and the price we are selling for. With this information, we are able to accurately predict the sales of apples for its price.
The next thing we want to do is maximize our profit. We know that profit is equal to the total revenue minus the total cost. So to know how to maximize our profit, we first need to know how to calculate these two, the total cost and the total revenue. Our total revenue is equal to the quantity the apples are sold at and the price the apples are sold at. And we can assume that we already know the formula for our total cost, which is a variable cost of $2 a kilo and a fixed cost of $9. This makes our total cost equal to 2 times quantity plus 9. Now that we know the formulas of total revenue and total cost, the profit formula still has 2 different variables shown in it, as you can see in the middle of the screen. The 2 variables are P and Q, and we need to define the variable quantity in the variable Q. Because we already know Q is equal to 35 minus 5P, we can implement this in the current profit formula. We will get a profit for the variable price which is minus 5P squared plus 45P minus 79.
The next step is to determine the point in which we are selling for maximum profit. For this, we will use a derivative. A derivative is used to calculate the slope of a line at any given point of a function. With this, you can also calculate the maximum and the minimum. At both of these points, the slope is 0, so the derivative has to be equal to 0. We know that in our working example, we have a downwards opening parabola, and we are looking to maximize our profit. So we'll use a derivative to find our maximum, thus finding the best price for us to sell our apples at.
Here we have applied the derivative to our profit function to maximize our profit. We have derived the function 2 times. The first derivative is to find the stationary point, and the second derivative is to confirm that the stationary point is in fact a maximum. With the first derivative, we found that the maximum was at $4.50 per kilo. With the quantity function, we found that we can sell 12.5 kilos a day at this price. And with the profit function, we found that we could expect to make a profit of about $22.5 a day.
Math can be used in even the simplest business models, as shown in this video, where we use the 2-point formula to make a linear function. After this, we then use our profit function, which is also a quadratic formula. We then use derivatives to find the maximum to optimize our profit. These are all separate concepts that have been taught to us by our lecturers in Math 123.